Okay, so what's a wave? A wave is basically a transfer of energy. So that's the basic understanding and basic principle of what a wave is. Now, as to the what are the types of a wave? Okay, so types of wave. So think about the ways in which the energy is transferred, and we'll just discuss these types using the examples. So the first is the longitudinal, I hope I've written the correct spelling, waves. Okay, so here's the thing. In the concept that is we've discussed of the wave, we've described as the wave to be a transfer of energy, and the transfer of energy basically is done by the vibration of particles or some movement. So we discuss vibration, but it's mainly you can describe it as some movement. So there is the particles in an object are lined up like this. So these are some like atoms on the atomic level. And whatever change I make here, that change is then transferred to this end. Okay. So
Okay.
think about a spring. So that's a spring that's attached to a wall or something. And you take this end and you stretch it. What's going to happen that the spring is actually going to extend. But the point is that you're actually making change to only this part of the spring. The rest of it is basically all how the wave actually travels back in the spring. So the transfer of energy within the spring is actually causing the wave to extend. Is it clear?
Yeah.
So longitudinal waves are waves where the vibration are parallel to the direction of the wave. So in this case, you will apply force in this direction, and the direction the wave travels in within the spring, the wave which causes the spring to actually sort of extend, the direction of that will be also parallel to this. So in this case, the vibrations are parallel to the direction of the wave that it travels, and such waves are called longitudinal waves. Okay.
Yeah.
Second thing is the transverse waves. Transverse waves are the waves where the vibrations are perpendicular. Perpendicular to the direction.
Isn't it to the direction of energy transfer?
Yeah. So the wave is basically the energy transfer. So you can just write, I'll just clear this up. Wave or the energy transfer. Okay. And direction of the wave / energy transfer. So think about like a rope tied to a wall or something, okay? And you sort of oscillate this end, which causes a wave here, okay?
Wait, can you just hold on one moment? I'm just copying this down.
Okay, okay.
Thank you. All right, yeah, you can carry on.
Okay. So now, if you have a rope and you sort of oscillate this, I'm sorry, what's happening? So if you oscillate this end of the spring, this will cause like a wave to form, like sort of a that will travel within the wave. So after a few moments, you'll see waves forming like this within the rope. And
Oh, okay.
so what you would see here is that you're actually oscillating in the vertical direction, but the wave is still moving in the horizontal direction. So in this case, the transfer of wave, the energy transfer, or whatever you would like to call it, is actually perpendicular to the vibrations or the oscillations that you're making. Okay,
Okay. All right.
so that's how we define a transverse wave and a longitudinal wave. Okay.
Hey, can you send me this PDF like on WhatsApp if you can?
Okay, let me just.
You don't have to do it now. Like you could do it at the end of the class.
Okay,
Just
okay,
like
sure. Sure.
okay. I'll
So,
remind you, so don't worry.
okay. So that's what we've discussed, what a wave is,
Uh-huh.
and the book says that the waves are basically something which are caused by a vibrating source. So this basically means that waves are something that are generated from an energy source, and the waves are actually causing the energy to transfer and sort of spread out in the whole thing. So if you take an example of this falling in the water. So if you have uh, like a cup of water, so you probably see this, we see this a lot here in our tea ads, where just they have a cup of tea that's
Uh-huh.
completely still,
Yeah.
and there's, as soon as the droplet falls in it, just they create something, the picture like this, where you see the energy that the droplet has, and it falls in the cup. It sort of gets transferred within the tea. So there are waves that are formed from the center like this, and it sort of travels in the to the out of the to the sort of outside of the cup, so that's basically how the energy is transferred. Okay.
Okay.
So that's what a wave is. In the book, they've described progressive wave is an oscillation or vibration that transfers. So the progressive wave is basically what they've defined what wave is. Okay. So there are types of waves which we've discussed. Now, what describes the movement? Okay, there has to be something that describes it. I think you've discussed, you might have seen this sort of a graph, and then you were studying trigonometric.
Yeah. I've seen it before.
So this isn't something that is not like new to you. So basically, here they've described the wavelength, the length after which the pattern repeats. So you see at this point, this is the starting point, and this is another point. And you see that after this point, this sort of pattern is repeating. Okay.
Obviously.
So
Yeah.
this pattern is repeated after this thing. So it's basically the same thing. So here, this means that the wavelength is basically difference between the wave peaks.
Ibadu.
Hello, yeah, just hold on for a second.
All right. Okay.
Okay, so this is the wavelength, and the amplitude is basically the height of this peak. So the maximum height of this peak is defined as amplitude. I'm sure you know this as well.
Yeah.
Okay, and you know about frequency and the period of a wave. Yes.
Yeah. T equals 1/.
Okay. So okay, now let's talk about some equations. So basically, here the distance upon time formula is basically used to determine the speed of the wave, and the distance is basically what we've described the wavelength, and we describe the period to be equals to the time that is taken by one wave to form. So whatever time this wave takes, whatever time this is taking, like till here, this is the period. Okay,
Uh-huh.
and so the wave speed is basically measured using this concept that the sorry, the time, sorry, the distance covered by one wave, distance covered by one wave divided by the time taken by the one wave. Okay, so we define this to be equals to the wave speed.
Uh-huh.
Okay, and the distance covered by one wave is said
Isn't
to
it
be the,
C equals F lambda?
yeah.
So how come we're dividing it?
Okay, then just let me just,
Oh, it's like a ms minus 1. That's why.
wavelength divided by the frequency.
Yeah.
Okay.
Because that's the unit ms minus 1. That's why.
Hmm.
Yeah, I get it now.
So okay, so the wavelength is basically represented by lambda,
Lambda.
and
Yeah, there you
frequency
go.
is, the frequency is basically f. Okay, no, oh, no.
No, you're right. You're right.
Oh yeah, I know, this is the time period,
Oh, I thought you were talking about the
which
frequency.
is equals to 1 over the time period.
Uh-huh.
So the wave speed is v, and v is equals to wavelength times frequency, which is basically lambda times f, or f lambda. Okay,
Yeah.
so this is the whole concept. Now, do you have any questions up till now?
Could you go back up to the definition of a progressive wave?
Oh, so the progressive wave is basically the wave that we describe. So a progressive wave in your syllabus is described like this. So when I studied waves, it was a simple wave, but to know there are sort of like types of waves where we have to discuss how the wave is transferred. So to just generalize this, it's called a progressive wave. And in the progressive wave, this is basically what a progressive wave is. It's basically which transfer the energy through oscillations and vibrations.
All right.
So
Wait, could you go
basically,
back onto the textbook?
yeah, sure. Okay.
All right. All right,
Uh,
just give me a moment. Sorry,
okay.
sorry, I was talking to my mom.
Take your time. Fine. Are you done?
Uh, yeah, I'm done.
Okay. So this is the concept of the wave speed, and that's basically told pretty much it about till the v is equals to f lambda. Now we're gonna talk about something called a phase. Okay, so what basically a phase is basically some fraction that is covered by the wave after it started.
Wait,
So
could you repeat that again? Sorry. I'm really sorry about that.
so a phase is something, the fraction of wavelength, actually how much wavelength the wave has covered. So
Oh,
phase, in the phase, and if this is your axis and this is okay, so this is your one wavelength, so you call this lambda. Your second wavelength will be 2 lambda. And if I talk
okay.
about this, so this, you will call this half lambda. So you'll say that, okay, half lambda means that this wave has actually covered half of the wavelength after it has started. If you're going to talk about
Okay.
this, so you're going to say it's 3 over 2 lambda. So the phase of this
Uh-huh.
point, let's call this point A. So the phase of A is actually 3 over 2 lambda, which means that the wave has covered 1.5 wavelengths after it has started. So this is the
Oh,
starting
okay.
point, the originating point O. And if you're going to describe the phase of A, so the phase of A basically means that you have to describe how the fraction basically of how much the wave has covered till how much fractions of the wavelength the wave has covered. Okay,
Okay.
so that's a phase. What a phase is, now there's something we call in phase, out of, and there's out of phase. Okay, so in phase are basically waves which have the same sort of the same phase at same point. So if there is a wave that started before this, at a point they have the same wave, they might like have sort of intersect at this with their waves, and we say that if they have the same phase, that means that they are in phase. And out of
Wait,
phase is basically,
can you re-explain this? So in phase equals out of phase.
no, in phase equals out, no, it does not equal out of phase. So in phase is basically the same when they are in the same direction and they have the same speed. So we call the waves
Oh.
in phase. Okay.
Do you have like a diagram that shows it?
Okay. I'm just trying to see your book, and then I'll try to alter it on myself. So yeah, like this. So here you see, let me just copy this to the whiteboard. Here you see a red wave and a blue wave. So as soon you see, after every point, the both of these wave have the same phase. They both have covered half lambda, and
Oh,
this
okay.
is lambda, and this is, both of them are at the same phase, so 3 over 2
Uh-huh.
lambda. So whatever point I take, I see that they are having the same phases at the same point, so I call these phases in phase. And out of phase is basically anything other than that, other than in phase, every other phase is called out of phase. So if you see another wave that's going like this, so you'll say that they are out of phase. Okay. And what's completely out of phase? Completely out of phase is basically sort of you will learn this better when we will study stationary waves. But for you, completely out of phase is something where the phase difference is 180 degrees.
Okay.
Okay.
Can you take a screenshot of all of these notes? Or like you'll have a copy of all these notes, right?
Yeah, yeah. So
Yeah,
phase
okay.
difference
That
of
works.
180 degrees or okay.
Yeah, and what about out of phase? Like what's the characteristic there?
So the out of phase characteristic is that when the phase are not in phase, when the two waves are not in phase, they are said to be out of phase. That's just the simple definition of out of phase thing. Out of phase waves.
Can you write that down right next to it? The same
Out,
for the same for completely out of phase.
out of phase or waves that are not in phase. That are
Okay.
not in phase. Okay.
Okay.
Do you get this?
Yeah, yeah, yeah.
Hmm. Now, what's a phase difference?
Isn't it just the difference between 2 points on on
Exactly.
like on it on the spectrum?
Yeah. So, but how do we define a phase difference?
Oh, isn't it through radians?
Yes. So it's described. It's the phase difference is basically you calculated using this formula. So it's said to be 2 pi x divided by lambda. Okay.
Okay.
So there are in the textbook, they are defined to be longitudinal waves and transverse waves. And there are types of obviously these waves where you will learn about them better in the textbook. So just to give you like a summary of it, we have discussed what longitudinal waves are and what transverse waves are, right?
Uh-huh.
So an example of transverse wave can be like in an electromagnetic wave. So where the electric field sort of oscillates in the horizontal direction, and the magnetic field that is caused by that electric field is actually vertical. So there is a completely they both are completely perpendicular. So
Yeah,
that
yeah.
so yeah. Now, what's a mechanical wave? A mechanical wave is something that needs a medium to transfer. So sound waves and make like a wave on a rope or something like that, they are all transferred through a medium. So these sort types of waves are actually called mechanical waves. Okay.
Right, okay.
Okay. So now let's talk about reflections and refractions in longitudinal waves. Okay.
All right.
So when you see a longitudinal wave, there isn't any graph or something that's made. This particular graph is only for the transverse wave. But when we talk about longitudinal waves, we see that these longitudinal waves are actually made measured through something called a wave front.
Wait, what's a wavefront again?
A
Could you
wave
repeat
front.
the last part?
So
Just the last part.
So I was saying that we describe transverse wave using the graph that I've drawn here. So this
Yeah,
graph is
yeah.
basically how we describe a transverse wave. For the longitudinal waves, obviously, when the movement or the oscillation are parallel to the transfer of wave, we sort of represent it on a graph paper using a wave front. Now, what's a wave front? Do you have any idea?
I don't really know. No.
Okay. So a wavefront is basically the vertical lines that are drawn at the peaks of it. So if we draw for this red, I'll just draw wavefronts for the red wave. So these are the wavefronts of this wave. These are all the wavefronts where these are just like vertical lines. So
All right. Okay.
so these are called wavefronts. Okay.
Uh-huh.
So longitudinal waves are actually quite interesting, where you see a pattern where you can see the wavefront at some points at a particular region. The wavefronts are the farthest apart, and at a particular point, the wavefronts are quite near to each other. So at the point where they're far from each other, they start getting closer and closer and closer to the point they're almost next to each other. So like this, and then after that, they start getting farther apart.
Wait,
So like
why do they get closer in the first place?
so it's simply like this thing, now. So the transfer of energy is not constant. So you won't see like a single line of wave. It's always like a change that's being caused by the energy transfer that like gives you this graph. So this graph is basically caused by the changes in the energy that it has. So even if you see this particular image where we discussed a wave traveling through a cup of tea. So what you see here is that this sort of like the pattern there is this is the pattern that's being depicted by this wave basically. So it's the highest here, and then sort of every time it gets sort of uh, the 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 pattern, the water sort of gets lower and lower, the amplitude gets lower and lower, and it's because that's how basically the transfer works. You won't see like a single
Oh, yeah, I can see it from the picture now. Yeah.
okay, we'll just zoom it
Yeah.
in a bit. So
Yeah, like the ripples are really
the
close and then
ripples,
they go
yeah.
outwards again. Yeah.
So you see there are points where it's on the low and then it's on the high at some point.
Uh-huh.
Okay.
Yeah.
Just wait a second. I have to use my phone. Can you hear me now?
Hello?
Hello, can you hear me now? Just I'm just use my headphones now.
Yeah, I can hear you.
Okay. So that's the basic concept of wave, and the points I was talking about on the longitudinal waves are so the points where the waves get closer. This region is described to be compression region, and the region where they are further apart, like this one, are basically
Uh-huh.
called the rarefaction. Okay.
Rare refraction. Okay.
Rare,
Yeah. Okay.
this word.
Wait, is it just refraction or refraction?
Refraction.
Oh, rarefactions. Oh, okay.
Okay.
Yeah, I get it. Yeah.
Okay. Do you have any questions now? Because I want to
No,
practice.
no, I just want to carry on really. I like the pace that we're going.
Okay. So, okay, now let's discuss about the some of the electromagnetic waves, and I hope you have an idea about.
I've seen electromagnetic waves on electromagnetic spectrum as well.
So, yeah, so they all have the same speed, c, which is 3 exponent 8 meter per second.
Uh-huh.
What changes is they are arranged in the field of, this is the increasing wavelength.
And and on the other side, it's the increasing frequency and energy.
Exactly. So this is the increasing wavelength. So if the wavelength, what the relation we've studied is c is equals to f lambda. So if this is concept, if this is a constant and
Uh-huh.
this is increasing, so automatically this would decrease. So
Yeah.
on this front, the frequency is decreasing. The decreasing frequency. Okay. I'll just copy it down to our whiteboard so we have a record of this.
Right. Okay.
So these are some of the parts which are important for your syllabus, obviously for the questions, but these are mostly theory that's written in the book. So there isn't like a lot of concept. So
I
how,
remember this from GCSE really.
yeah. So these are the ways how they are basically used in different places. So like the radio waves are used in the communication, and microwaves are used to heat stuff because in the microwave oven. So that microwave oven is actually an application of an electromagnetic wave. Okay.
Yeah, microwaves.
So now, now this is again polarization. Polarizing is basically how a wave is charged. So a wave can also be charged, and how that charged wave travels through it. Okay.
All right.
So that's basically the okay.
So you're muted.
Yeah, I am. Wait.
So you're still muted.
Yeah. Okay, let's start now with reflection and refraction. So the reflection is basically a simple concept. The reflection of wave you studied in GCSEs as well, and a part of the refraction is also this basically is from your syllabus. What I've learned is basically the refresher from your GCSEs. Okay.
Yeah.
So the reflection basically is what how you define reflection. Reflection is basically what causes reflection is something that causes a phase difference of 180 degrees. Okay. So a wave and a reflection of that wave will be completely out of phase with each other. So if you have a rope that's traveling in a wave like this, and it hits a wall at this point, then it gets.
Sir, do you mind putting in like some earphones or something? Because I can hear someone in the background.
Okay, let me see.
All right, thank you.
Okay, sorry about that. So whenever
Yeah, that's fine.
a wall, whenever a wave like hits some surface that causes the wave to reflect, the waves that form after reflection will be completely out of phase. So if I talk about this red wave, after reflection, this would go completely out of phase with the wave that's causing it. So it will be like this. Okay, so it's gonna travel out of phase like this.
Oh, okay.
Okay, so this is something part of the syllabus now, and I think you've studied this in GCSEs as well.
Uh-huh.
Second thing is the refraction. Refraction is basically how the light is. Refraction is basically how waves behave in different mediums. Okay,
Okay.
so you've studied lenses. The lenses are a big application of refraction, and I hope you've studied optics in your GCSEs, right? So how, like, this is like a glass box and the light enters, it sort of changes its course. Sorry, this is a terrible diagram. So it changes its course a little bit, and then after it leaves in a different direction. Okay, so the refraction or the medium change, because the medium was actually, here it is air, and here it is glass or water or something. Okay, let's suppose it's a glass. Okay, so the angle that it forms with the normal is actually different from the angle that it forms within the glass. Theta 2 and theta 1. The property is of air in glass that theta 1 is always greater than theta 2. Okay.
All right. Okay.
Okay.
Yeah.
So this is the concept of refraction. There are some calculations and equations that you probably studied as well. The number one thing is the refractive index. So the refractive index is something which is commonly used in the industry to describe materials, especially in optics. So where you see objects that come into with labeled how much the refractive index is. Okay.
Okay.
So I think this is it. And the law of refraction, have you studied the Snell's law?
No, I have not.
Okay, so the Snell's law says that the sine theta 1 divided by sine theta 2 is always constant. For something Snell's constant, it's called it's a Snell constant of the particular medium. Okay,
Uh-huh.
so it's always constant for this, and you can, if you have the refractive index, if you have the sort of, if you know the thetas and the angles, you can find the signs of it, and the ratio of the signs will always be a constant. So if I give you theta 1 and theta 2, and I give you this theta 3, and I ask you what's the angle with which the light leaves, so theta 4. So you can use this law to find theta 4. Okay.
Okay.
Now, total internal reflection you have studied, I'm supposing.
Oh, I
Hello.
think it's come to the end of our hour.
You have something to do, because I think we have a chapter left.
No, like as in we're only set for like 1 hour lessons. But I can teach the last section of myself. It's fine, I don't mind.
Okay. So the thing is that there are. I'm gonna send you this book, and
Uh-huh.
in the next section, I was hoping we could study chapter 6 as well, because this has stationary waves as well, interference and superposition, and then we
Uh-huh.
study. So this chapter was basically a refresher for your GCSE waves concept. Everything that we
Okay.
studied today is basically what we cover in GCSE. So we talk about reflection. We talk about the electromagnetic wave spectrum and everything. I don't remember if you guys study compression and refraction, but when I was in GCSE, I did study that. So this was basically a sort of a refresher, a revision for your GCSE concept of wave. In next class, I'm hoping we could like go to some advanced concepts. This is the superposition, interference, stationary waves, and there are obviously laws of stationary waves as well.
Okay. All right. Yeah, sure, definitely.
All right.
You do, would you like to do one on Thursday?
We can do what on Thursday, sure. I'll just tell you the
Okay.
I'll just tell you the time that we can do. I'm hoping
Uh-huh.
to do it like on the same time, but I think I'll just discuss it on the group.
I'm hoping we